Hello students, I am Anchal and today we are going to start one of the most important and most beautiful reaction of carbonyl compound. This is the reaction in which one molecule reacts with itself and form carbon-carbon bond. And remember, the formation of carbon-carbon bond is the heart of organic chemistry. So yeah, we are going to start aldol condensation. Now, why it has named as aldol? Do you have any idea? It is because of its name. Aldol consists of two functional groups. One is the aldehyde and one is alcohol. Aldehyde is the prefix of aldehyde. ELG is the prefix of aldehyde and OL is the suffix of alcohol. So combinedly they both give as aldol. Coming on the condensation, aldol condensation include two kind of steps. One is addition, named as aldol addition. Second is condensation. So basically, removal of water termed as aldol condensation. So this was all why it has named as aldol condensation. Talking about the general reaction. General reaction. We are taking aldehyde or ketone reacts with dilute base, can be NaOH or KOH, giving you beta hydroxy carbonyl compound, and on further heating you will get alpha beta unsaturated carbonyl compound. So this is the general reaction. There is a one most important condition for going through aldol condensation, that you should have at least presence of one alpha hydrogen. Condition: you will always have at least one alpha hydrogen. Now students, what is alpha hydrogen? Let us understand by taking an example. CH3 CHO. This is what? Acetaldehyde. Okay. Alpha hydrogen is, now let us understand what is alpha position. The carbon which is just adjacent to sp2 hybridized carbon. This is sp2 hybridized carbon. So the carbon which is attached to sp2 hybridized carbon is known as alpha carbon, and those hydrogen which are attached to this alpha carbon is known as alpha hydrogens. So here we have three alpha hydrogen, and these three alpha hydrogens are most acidic in nature. Okay, how we can able to tell this is most acidic? If we will remove this hydrogen, negative will come here. This is what? Invalid ion, and this negative will go further into delocalization, providing it more stability. CH2 double bond C O minus, and this is what? And we can term as here tautomerism is also happening, or keto-enol isomerism. So this is the must condition. Now coming on the definition of aldol condensation, it is a kind of condensation in which aldehyde or ketone react with dilute base, that will be NaOH or KOH, giving you beta hydroxy carbonyl compound. On further heating, after removal of water, you will get alpha beta unsaturated compound. So then aldehyde or ketone reacts with dilute NaOH or KOH, giving beta hydroxy carbonyl compound. On further heating, resulting an alpha beta unsaturated carbonyl compound. It is of three types. First is self-aldol, Second is cross aldol, and third is very important for JEE or NEET perspective, that is intramolecular. Intramolecular aldol. Let's go with the self first. So coming on self aldol, I have taken here 2 mole of acetaldehyde. So the first step is the formation of enolate ion. Formation of enolate ion. Already we have discussed this one. CH3, CHO. React with base. Now base wants what? Base wants always acidic hydrogen, and acidic hydrogen is here. This is acidic hydrogen. This will come and it will attack on this acidic hydrogen. This hydrogen will remove out, leading to form enolate ion. So this is enolate ion, and it will act as nucleophile. This was our first step. Moving on to the second step, that is nucleophilic attack on carbonyl group. Nucleophilic attack on carbonyl group. Here again we will take that enolate ion. Now, the carbon of this carbonyl compound is electrophilic in nature. Why? Because if I will break this bond like this, if I will break this bond CH3, the electron density will shift on oxygen, because oxygen is most electronegative as compared to carbon. And on here, this nucleophile will go and attack on this carbon, and it will form CH3, C this O minus, H is here, and then CH2, CHO. CH2, CHO. This is what? This is called as alkoxide. Now, H plus, reacting this with H plus, this H plus will go and attack on here. It will combine with alkoxide group and it will form CH3, CHOH, CH2, CHO. Students, this is known as what? Beta hydroxy carbonyl compound. This is known as beta hydroxy carbonyl compound, which is, until this step we will know, it is called as aldol addition. Aldol addition. Why aldol addition? Means aldehyde and alcohol both is present. Aldehyde as well as alcohol, both functional groups are present. So students, third step was protonation. Coming on the fourth step, this is elimination. Elimination of water. And this elimination of water will be done by even CB mechanism. Even CB mechanism, how it will go? CH3, CHOH, CH, I will write this hydrogen like this, and then CHO. Now, remove this water. Remove this water. After heating, minus H2O, you will get what? CH3, CH, double bond, CH, CHO. So students, once again, this is alpha, beta, unsaturated carbonyl compound, and this is what our aldol product. Now, the formation of this alpha beta unsaturated compound is driven by, is thermodynamically driven, because here what we got conjugated system, that is why it is thermodynamically driven. Coming on second type of aldol condensation, that is cross aldol. Here students, what we are taking two different kind of reactants. Here the reactants were same. Here I will take two different kind of reaction. Means first I will take acetaldehyde. Let us take one is acetaldehyde CH3CHO, and second I will take like propanaldehyde. I can take CH3 CH2 CHO. Now here you will get two kind of products, product 1 and product 2. How? See, Here also alpha hydrogen is here. So if here alpha hydrogen is here, 1H, if you will remove this hydrogen, what you will get? You will get first enolate this one, and then this enolate will attack on this carbon. You will get first product. And what? Let us and again the second product. Here also it is having alpha hydrogen. Here one alpha hydrogen is also there. So if you will remove this alpha hydrogen, this negative, it will attack on this carbon. So you will get two kind of product. So I just want you to do by your own, students. Moving on the third part of aldol condensation. Moving on third type of aldol condensation, that is intramolecular aldol condensation. So by the name we can understand intramolecular. Intramolecular. Intra means, student, intra means itself. Means within the molecule. Within the molecule. And student, this is very important for JEE and NEET perspective. Let us understand by taking an example. See, this is the reactant we have, and we can have two kinds of products, product 1 and product 2. See, here we have two aldehyde in the same molecule. Two aldehyde in the same molecule, that is what known as intramolecular aldol condensation. What are the possibilities of attacking? Here I have alpha hydrogen. Here I have alpha hydrogen. And here also I have alpha hydrogen. Okay. So if this will attack, so we can have the attacks like this will come and attack here. This is first, let us take, and this will go and attack here. This is second product. Let us make the products. If first will attack on this carbon, what we will get? This will go as O minus, and then after protonation it will be OH, and further on heating elimination will happen, and after elimination you will get what? This removal of water, and the after removal of water you will get this as the aldol product. Now coming for the second, if this will attack on this one, see. Again this O minus will come. After protonation it will become like OH. And after then on further heating you will get what? You will just after removal of water you will get alkene, and alkene will be here. So this is the aldol product. Now student, which is now here the question arises, which will be stable, which you will get in better yield. This will come as major product, and this will come as minor product. How I have decided? Students, always remember 5-member ring, 5 or 6-member ring are always stable. 3 and 4-member ring actually do not exist. Why do not exist? Because very much angular strain is there. So that is why 3-member and 4-member ring are not stable. They will not form. 5-member and 6-member ring they will form. So yeah, this was a further reaction, and students, today we have learned that aldol condensation is basically the formation of new carbon-carbon bond. And student, if you have understand this, the formation of enolate ion, then half of the organic chemistry, that for the carbonyl compound you'll be able to do the questions. And I would like to tell you what are the majorly part students are doing mistakes, that either they are not considering the alpha hydrogen, and secondly they are not going with the proper mechanism. So if you will avoid these two mistakes, you will be able to do question properly. And I just want to tell you a trick also how to do the question. Coming on the trick. Again I am taking the acetaldehyde, CH3, C. I am just writing this like this so that it will be easier for me, it will be convenient for me to make you understand. To just see here, both are acetaldehyde reacting this with dilute and leave it. What you have to do, you have to remove water only. Okay, so arrange these two acetaldehyde in such a way that the first acetaldehyde will show that C carbonyl group and the second acetaldehyde will show like a alpha hydrogen, both two alpha hydrogen. Just remove water from here and you will get what? Product CH3, CH, double bond, CH, CHO. So this was what we already discussed in the first. And one more thing is, students, what if you do not get alpha hydrogen? Will it undergo Aldol condensation? No, it will not undergo Aldol condensation. So what happens? It will undergo in Cannizzaro reaction. Like one product is oxidized and one product will reduce. That we will discuss in our next. So that's all for today and thank you everyone.